So the first question comes from Lucia. What is the number of effective picks per minute? What is the number of streams that can sort each arm? Maximum throughput in plastic bottle applications? Food grade VC non-food grade packaging recognition? And I think it's a good question for you, Juha.
Okay, good question. So the, let's say, maximum effective speed is around 70 picks per minute. That varies, of course, then let's say the theoretical speed can even be even much more, and then depending on the feeding and in the let's say consistent feeding, or how consistent the feeding is, how many picks and how many target objects there are, how that will then eventually let's say affect on the actual picking speed. But let's call it 70 picks per minute as a number. Then regarding discrete sorts or fractions, so the fast picker has currently 2 chutes, one on each side of the system of the sorting belt. It was really designed like that so that it fits a single sorting bay. That's the reason. The software itself, of course, is able to recognize multiple let's say different categorize the material in many ways. And since we have this gantry type setup, we do have a version coming up later, which then will have more chutes. So namely, we are talking about 4 different chutes, but this current version has two chutes. Then max throughput, next part of the question. So it, of course, again varies then on the average weights of the materials and so on. Let's say if we look at the physical restraints, physical elements here, so we can work the opening in the machine, in the robot, is 1.4 meters. So you can fit in the conveyor frame, sorting belt conveyor frame can be 1.4 meters wide. The belt may be effectively then 1.2 or something like that, depending on the conveyor manufacturer, on the design of the conveyor. And then the belt speed is about 1 meter per second, plus minus. And that then, of course, determines the, let's say, the surface that goes through the robot per hour. And then, let's say a monolayer would be, a single layer would be really the target on this sort of plastic bottle sorting application for the robot to really see all the objects and then to be able to pick the target objects. So who am I to say? I would say that maybe 1 or 2 tons an hour maybe is the let's say the ballpark answer here. And then on what the robot is able to distinguish, the rule of thumb would be that if a human being is able to differentiate between food grade and non-food grade by just looking at the objects, or in this case, I guess the plastic bottles, then the robot is also able to do the same, more or less. There might be some very specific cases where maybe the human is better in terms of recognition, and then many cases where the robot is actually more consistent and better.
Thank you, Juha, for the great answer. And let's continue with the next one. So the next question comes from Simon. What is the maximum conveyor speed? What maximum weight robot is capable to pick?
Thank you, Simon. That's a good question. According to our specifications, the maximum belt speed is 1 meter per second. However, that is not necessarily a hard stop concerning the belt speed. We are happy to look at your specific situation. So, for instance, if you send a video of the current situation and tell the exact belt speed and the sorting task, we are really happy to evaluate it. So I think we will be fine. The maximum weight of the objects that the robot can pick is, again, according to specification, 1 kilo. We have seen the robot picking even bricks. So it is a very powerful gripper. Of course, when you are picking waste, there might be leaks. You cannot necessarily seal tightly against the objects, but that's in most cases quite okay, since our ejector type gripper has a very high gripping power to compensate for those leaks. So that should not be a problem. Then talking about gripping, we of course have the other robot, which we call the heavy picker, which has a crocodile type jaw gripper, which physically, like a crocodile, grips around the objects and holds them very, very firmly. That robot type we use for example, construction and demolition waste sorting or metal sorting or some other heavy objects. And that machine can handle weights up to 30 kilos.
Thank you, Rainer. And let's continue with another question. And this question comes from Karl Heinz. I'm interested in your project and to see if vibrating technology could improve your process. And this is a question for Thomas.
Excellent question. Yes, the answer is yes, definitely yes. As you know, feeding is always important. Spreading the material evenly before it arrives to the sorting belt is really crucial. That means definitely yes, vibrating technology can help, and we're happy to get in contact with you, Karl Heinz. Later, feel free to shoot us an email or reach us via social media whatsoever. We are happy to talk more about concrete projects with you. Thanks for that good question.
Thank you, Thomas. That was a great answer. And let's keep on going. The next question comes from Kalyane. Hello, at what point are you developed and where are your products currently? Rainer, this is the question for you.
Thank you, Kalyane, for a very good question. Well, we started developing robots for waste sorting in 2008, 2009. And in late 2010, we came out with the first robots for waste sorting. However, in those days, we still used standard industrial robots, basically off-the-shelf robots that are fine, excellent robots for the tasks they are designed for. But very quickly, we found out that the requirements in the waste industry are different. The conditions are very, very harsh. It's dusty, it's dirty, you have humidity, you have crashes, it's very hot, it can be very cold. It's not no way close to a clean, nice, tidy production facility. It's simply dirty and rough. And by definition, waste, you don't know what it is. There can be anything on the sorting belt. And when you need to be fast while picking, those surprises, say a crash into a surprising object, they are pretty violent, as you have to be fast at the same time. So this was the reason why we in 2014 came out with our gantry-style robots that are very, very durable. They are built to last the harsh conditions in the waste industry, and they are also very, very simple to maintain. So strong and simple robots, that was the thing that proved that would be the solution that works in the hard, very hard conditions of the waste industry. We have had those gantry-style robots for years and years in operation all around the planet. A big number of them. So we have collected experiences and we know what works and we also know what doesn't work. That's even more important information. And the fast picker robot, we launched a small number of them, a dozen or something like that in 2008. And they have been now operating in real waste facilities, sorting real waste, real conditions, real picking, and we have millions and millions and millions of picks which we need to prove the machinery. And today, the fast picker is a mature product which is ready for deliveries in large numbers.
Thank you, Rainer, for the great answer. And let's continue with the next one. And the next question comes from Ivan. Will it be possible to place 2 or 3 arms like in heavy picker? Will it be able to separate each arm more than 2 residues at the same time? Over time, the robot may have the same separation efficiency even if the material does not circulate in one. I think this is the great question for Juha.
Good question. Easy to answer this time. So the fast picker unit comes with one vision system and 1 arm. That's the package which then fits into the single sorting bay in the most effective way. And currently, our approach is such that if you then require more arms in order to have more capacity, more picks per hour, or if you need more commodities to be pulled off, to be recovered in the same, let's say, sorting bay or in the sorting cabinet, then we would just include and add more robots to let's say, make that happen. So currently, one arm, one vision system, yeah.
Thank you, Juha, for your answer, and we'll continue with the new question, which comes from Tiago. And Tiago is expressing interest of sorting line for mixed post-consumer plastics. And I think that's the great question for Thomas.
Yes, that's definitely an interesting application for us. We have done it already in several countries in Europe, and in both QC applications, but also residue recovery. I think both aspects of both applications are interesting in this context. It's about high purity that we can ensure by quality control, and also really increasing recoveries to really strive for maximum recovery, in particular in light of the EU circular economy package, as said earlier. That means, yes, that's very interesting. Please feel free to reach out to us, leave us your contact details unless you did that already. So yeah, let's be in contact after the webinar. Thanks for that good question, Tiago.
Thank you, Thomas, for your answer, and we'll keep on going with the next one. And the next question comes from Mael. Why ZenRobotics FAST PICKER instead of other existing robotic solutions? With your previous advance in waste AI robotic sorting solution, why did it take ZenRobotics so long to arrive on the market, the French one, with its FAST PICKER? And it's the still good question for you, Thomas.
Yeah, Mael. Interesting question, to call it the least, and I'll try to. It's a pleasure for me to give you an answer. Of course, we can then continue this discussion and take it from there in a separate, breakout session if you want. Yes, we have a lot of experience. Yes, we were the pioneers. We were you could say, the ones that let's say were the first to apply AI-based robotic sorting in waste management. As you know well, we started out with the heavy picker and delivered systems on 4 different continents in more than a dozen countries, including, of course, France, as you know. And yeah, it took us a while. And of course, sometimes the market teaches you which direction to go. In this case, it was a little bit like that. There came pressure, obviously, from competitors who really brought us also, and onto this very interesting application to use sorting robots for DMR recycling, dry mixed recyclables recycling. And we started with the fast picker development in 2017, had the first pilots in the fields throughout late 2018 and then numerous in 2019. Learned a lot from it, gained a lot of experience also regarding the French market and the French flow. And I can also inform you that working with ZenRobotics on the French market is easy. Why? Because we have a team, we have somebody in sales that speaks fluently French. We have technical colleagues. We have that are French, both 2 guys that live even in Helsinki, but are really ils sont des Français, des vrais Français. Donc on peut parler avec eux sans problème. Donc ils sont très heureux de recevoir vos questions et de vous accompagner sur vos projets sur le territoire français. Donc yeah, so let's go from there. Let's take it from there, and let's trust us. We're going to land quite a few new projects in France in the very near future. Donc merci pour votre question. Thanks for your question, Mail. Bye-bye. Au revoir.
Thank you, Thomas, for your great answer. And we'll continue to the next question. The next one comes from Olaf. How do the robots work? And Juha, this is the great question for you.
A good basic question, and maybe it's good to recap at this point how the robot actually works. What are the main parts of it? So naturally, everything starts with the scanning. So the sensor collects visual images of the objects, and then the AI, so the software, then based on the images, defines how to categorize the objects, basically what the objects are, and then also instructs then the mechanical arm and the gripper to grip the objects from a specific location, and then also gives the instruction for the arm to throw those objects to the desired locations to shoot on either side of the conveyor. So quite simple.
Thank you, Juha. And the next question comes from Dirk. What is the delivery time? Juha, can you please take this one too?
The delivery time, the standard delivery time, is some 12 weeks or so. And the next delivery slots that we have available are in September this year, end of September 2020. That's when you can get the next machines from the production.
Thank you, Juha. The next question comes from Steve. Who should I contact if I need one? And Juha, please take this one.
Yeah, so when you need a fast picker or a heavy picker for that matter, or if you need one or many, a very good place to start is by sending us an email at sales@zenrobotics.com, or give us a call on our sales hotline, which number can be found on our webpage, which is zenrobotics.com.
Thank you, Juha. And now moving forward to the next question, which comes from Heyman. In which way your robot is better than Tomra, MaxAI, or competitor? And Rainer, this is a question for you.
Thank you, Heyman, for this question. A very good one. We actually do not want to compare ourselves with any other machinery or any other supplier. All products are good, all companies are needed, all have their strengths and weaknesses, and that's perfectly fine. You just need to pick the right product for the right purpose. We develop ourselves the whole product. So it is our gantry, the mechanics, the moving parts. It is our own gripper, designed specifically for waste sorting purposes, nothing that we have picked from other industries and trying to use. It is all designed for waste specifically. Also the automation, also the AI, the very, very advanced software we're using, it's made in-house, it's ZenRobotics product, everything. And also the sensor system is built totally by ourselves. So we believe we are the only robot manufacturer, which does the whole package in-house, which makes it way easier to control the features of the product. So we do not need to make compromises because there happens to be a supplier which happens to have this component. No, it's all designed, purpose-built for waste sorting. So I believe we are in this sense pretty unique.
Thank you, Rainer. And I also believe that we are unique. But moving on to the next question. And this question comes from Tom. Why wouldn't I buy an optical sorter instead? And Thomas, could you please take this one?
That's an excellent question. We were kind of anticipating that question, of course. And let me explain it in the following way. Optical sorters and AI-based sorting robots are not really competitive products, but I would rather see them as complementary products. Of course, there may be overlapping areas like in many other cases. But of course, if you really consider the quantity of material an optical sorter can treat. This is a completely different game compared to a robot. That means, yes, we need good upstream processing prior to the material being fed to the robot. That does include the deployment of NIR sorters. And nevertheless, we know that NIR sorters would only make it to a certain level of purity without too much loss of product. That sounds a little bit, you're an expert, I guess, when you ask that question, but you can have 3 optical in cascade, let's say it's 3 in a row, but the third one would not necessarily make the situation better than the second. And this is really when the flow already has been treated, let's say, thoroughly. There are still some contaminants. The robot is really, I would say, the best means to take those remaining impurities off the belt without having those collateral mispicks that you would always have when you eject with pressurized air. What the robot really is supposed to do is to replace human labor on container lines. So we don't see the system yet necessarily on film and film lines. We see it really at the moment as it is for 3D, let's say, materials. That means PET bottles, HDPE containers, beverage cartons, whatnot. There it is a great asset, does a great job. And also, let me also bring your kind attention to the following aspect. The robots are more retrofit friendly than an NIR in an existing environment. What we did a couple of times was really inside a sorting cabin. We just installed the robot and replaced the manual sorting bay by the robot. That worked, and you don't have to change conveyors. You don't have, let's say, to have 1 in-feed conveyor and at the minimum 2 out-feed conveyors. You don't. We can utilize the same existing sorting conveyor, and we can, most of the cases, we can use the existing chutes as well, or only have to adapt those chutes slightly. That means there is room for optical sorters. There will remain room for optical sorters in the future, but there is also space for AI-based sorting robots that do the job and take it from where the NIR sorters, let's say, leave it. So hope that is answering your question, but great question. Thanks for that a lot.
Thank you, Thomas, for your answer. And the next question comes from Gary. What do you think about the growing trend of robots and how it affected your company? Rainer, this question is for you.
Thank you, Gary, for that question. A very good one. Yes, indeed, we have seen a big change in the attitude during this spring. People now want to have robots more than ever. So it's not considered maybe that safe to keep people working side by side in a sorting cabin and touching waste of other people. So yeah, we have seen a big change here, and I would say this spring was the final breakthrough of automation, full automation, robotization of the waste sorting.
Thank you, Rainer, for your answer, and let's move on to the next question. The next question comes from Joanna. Is it possible to retrofit by ourselves? Rainer, this is a good question for you also.
Thank you, Joanna, for a very good question. We actually have designed the robots to be really, really easy to install. So they should fit on a standard hand sorting belt without any major modifications. So we don't want the integration cost to be high. So that has been one of the key drivers of the design, to make the installation really, really easy. However, as we have a big team of people who are experienced in installing robots, we recommend that you let them do it. The end result will be better because there are certain things that need to be considered, and as our people have this enormous experience, let them do it, and then you can just enjoy the end result.